So here we've got the production of a metal ceramic restoration. This is what you should have been doing in the laboratory sessions, and we'd be making a metal restoration for the K9 here, and you can see that this wax pattern has been produced. It's actually been produced by CAD. It's got a cut back here for the ceramic veneer to go on, and you can see the finishing edge, and the platal surface is made up of metal. So this is really to do with the design of the restoration. This is a clinical decision as to how the restoration should be constructed. So on this example of the central incisor, you can see this one's got a metal platal surface where the contact would occur with the lower incisor, and then we've just got the veneering ceramics over the incisor edge and down onto the labial surface, in comparison to the one next to it where we've got the ceramic coming all the way over, the metal's being cut back further, and we've got this simple metal collar on the platal aspect where we have that chamfer and the minimal reduction that we create for the metalwork. So here's some other examples of different designs. These are all the same bridges, as you can see, but they've got slightly different designs. This one has a metal guiding surface on the canine, as does that one. That one's also got a metal occlusal surface for on the premolar. Slightly different on this one. You can see we've got the collar on the premolar. This one has the ceramic all over. So you need to decide what material you're going to use for the contact points in ICP and in any lateral or protrusive excursion on your restoration, and communicate that with your technician so they can design the restoration appropriately. So it's going to be tough and robust for when it's in service. So the metal gets cast just as the lost wax, just using the lost wax casting process as we did for the full gold crown. The remnants of the sprue here that you can see needs reducing, and then the surface that's going to be bonded to the ceramic needs to be conditioned one way or another, and we grind with appropriate burrs to create the correct surface roughness all over, and make sure that there's no porosity or debris in the surface. If we're worried that we're getting a little bit thin, we can use some calipers just to check the thickness of the metal. We don't want to go down below 0.3 of a millimetre with these these nickel chrome base metals. And we just ensure that anywhere where it is bulky, where the metal might show through the ceramic, we just reduce. And then to condition that surface ready for bonding, we shot blast with this stuff, which is aluminium oxide. There's different sizes of aluminium oxide, different particle sizes and different shapes, and this one's got an irregular shape, so it roughens the surface. You can see it gets blasted out under compressed air. It's a messy business, so this is done in a cabinet with some vacuum on. I'll just do a little bit so you can see all the particles coming out like so. And we blast all the way over the surface that's going to be covered with ceramic until we have a nice consistent finish, and you can see that it's matte there, and it's got all this sort of small retentive features on there that the ceramic can grab onto. It gets washed thoroughly before it goes into the first cycle in the furnace, and this is the degassing stage and oxidation stage. So it goes into the furnace. We have a chart which tells us the firing parameters for this particular metal and ceramic combination, and that allows any gases trapped in the surface of the metal to diffuse out, and it also creates an oxide layer on the surface which acts as a wetting agent for the ceramic, so we can create a strong bond. At this stage, when it comes out of the furnace, we don't want to touch the surface of the metal that's going to have the ceramic on, otherwise we'll contaminate it and we won't get a good bond. We're going to put this first wash opaque layer on first before we put the opaque proper on. So that's the opaque proper. So we just use a small amount of this, and this really just creates the bond onto the surface of the metal. It's not for aesthetics or anything particularly. It starts to cover the grey of the metal, but you'll see when it's on, it's only a very thin layer. So this gets mixed with a particular fluid which is slightly acidic. We use a brush or a glass rod or a particular spatula to mix the ceramic powders with the fluid. We don't use any old metal because ceramics are actually coloured with metal oxide, so if we use a wax knife or something, we'll end up discolouring the ceramic. So as you can see, this is a very thin layer of ceramic material that we're putting onto the surface of the restoration. So it just wants to be reasonably even. Make sure we're down to the margins and to the finishing edge all the way around. And then that's going to go into the furnace and be cooked. So that's another sort of 15-20 minute cycle or whatever it is. And this is it after it comes out. You can see that it's just got this thin layer on. And we can touch this and so on now because we've created the bond between the metal and the ceramic. So now I'm mixing up the opaque material. And again, that gets mixed with the opaque fluid. Just mix that so it's a reasonably firm paste. And these ceramic particles now are in suspension in the fluid. And what we do is, well, if there's too much fluid, blots them out. What we do is put the ceramic slurry, this paste, onto the metal surface, and then we try and blot as much moisture out as possible and vibrate the ceramic particles at the same time. So the ceramic particles go down onto the surface of the metal and the moisture comes to the top. So you might just be able to make out there that it's shiny at the minute, and we just blot the side of the ceramic slurry until some of the moisture comes out and it starts to go matte, and then we can just vibrate it very gently with the serrations on our tool there, and that encourages the moisture to come to the surface and the particles to trickle down onto the metalwork, and we can blot it again. And we do that a couple of times to try and get a dense layer of the ceramic, because we want it to have good masking power to block out the metalwork underneath, the metal colour underneath, but we want it to be nice and thin, so it needs to be a dense layer, so closely packed particles of ceramic over the metal surface. A little bit of vibration there, and then just blot the moisture again. And essentially we rinse and repeat until we've covered the entire surface, and it wants to sort of look like an eggshell really. You can see the moisture just about disappearing there. It goes from a shiny surface to a matte surface. A little bit more vibrating, moisture out, particles to the surface, a nice thin but closely packed dense layer of ceramic particles. Next layer on, well, not a layer, bead on down the side. We're gradually working our way around this buccal surface of the canine. Okay, so obviously we've got the distal aspect to do as well, distal portion to do. So I'll just do that and show you the finished item. We can just smooth any imperfections out on the surface, and then that goes in the furnace and gets fired, and it comes out looking something like this. So that's a hard ceramic on there now. It's been through the furnace cycle, 20 minutes in the furnace or so, maybe a bit less. And then we make sure that everything's fully seated, the die's in the model correctly, the restoration's on the die correctly, and then we can start building up the translucent ceramics. So we start, I'm just going to use two here. I'm just going to use the base dentine, which gives us the colour. In this case it's 3M1, so it's not very it doesn't have much colour saturation to it, and this gets mixed with a different fluid, just some modelling fluid. And again, we mix that, and it needs to be sort of like wet sand really once it's mixed. And with our brush we can model this to shape, and what we try to do is get the correct shape but make the restoration at this stage about 10% or so bigger than we want the desired restoration to be, because as we sinter the ceramics in the furnace, the air comes out from in between the ceramic particles and the ceramic sinters together and becomes homogeneous, and as it does that it shrinks down. So here, to build up the ceramic, we say this is green state ceramic when it's unfired. We just use the brush as a little tool. You can see I've just got it as a point, and we can pick up the ceramic particles, place them on the metal restoration. You can see I'm holding the tissue behind, and that's gradually blotting the moisture out of the ceramic slurry as I work, so it's getting more and more stable as the moisture comes out of the ceramic slurry. And I can just use my brush as a tool just to shape the powders into the desired shape. Get some of the moisture out. Could do with some softer tissue really. And then we can just flatten the brush off and shape like so. I'm not worrying too much about the incised ledge at this stage because, see, I was just trying to smooth out there, but the ceramic powders were still a bit wet. I'm not worried too much about the incised ledge because we put some translucent ceramics at that incised ledge, and it's called the enamel shade. We don't use it as enamel. We don't put a layer all the way over the surface of the ceramic. We just put the ceramic powder, this enamel powder, where we want translucency to be. So just up at the cusp tip. So that's why I wasn't particularly fussy in the dentine powders of creating the correct shape. So I'm just going to make some room because I've put a little bit too much of the dentine shade on, so I'm going to cut a little bit back, make some room for this translucent ceramic, and then we can pick it up and pop it in place. The different colours, the ceramics are different colours in the palette, pink and pale blue, just so we can tell the difference. The manufacturers put that pink colouring in, it's just a food colouring or something that burns out in the furnace, just so we can spot the difference while they're in the palette, otherwise all the ceramic powders will just look identical. So you can see now I've got the translucent material on. I'm just doing my final shaping. It's a little bit big because we want to compensate for the shrinkage in the furnace, and also I tend to put a little bit of excess on, and that gives me room for grinding and shaping the surface of the ceramic once it comes out of the furnace, and it means that I don't have to carry out an addition, because once we've fired this ceramic we can add on and do another firing, but of course all these things take time and it's an extra cycle in the furnace, so if we can get it about right first time then all the better. So I'm just finishing off getting the shape reasonable, blending it into the finishing edge between the metalwork and the ceramic, and then we take it off, take the die out of the model so we can check the contact points and the sides of the restoration. Easy on this one at the distal because we've got no standing tooth there. Again, just blotting as we go. And then we can use a big dusty brush like this just to take any particles off. that are on the surface, and it also just condenses the ceramic particles down a little as well and dries the ceramic out as we go. And then we can pop that in the furnace once we're happy with the shapes, and then that goes in for another 25-minute cycle, something like that. Once we've got a bulk of ceramic like this, we have to heat the material up slowly so it dries out slowly, and we also need to cool the ceramic down as it comes out of the furnace. Remember, it's going up to about 1000 degrees to avoid it fracturing. And then once it's out, we use the burrs that you use for your veneer to shape and adjust the surface of the ceramic and put some detail in. So I'm just looking for the long axis of the tooth and creating those sorts of flat surfaces we see either side of the long axis of the tooth on the canine here, making sure the incisal edges following the arch form. This looks a tad long. I'm just going to take it down a little bit. I get a bit carried away when I'm trimming the labial aspect, and you'll see that you can actually see the opaque layer just shining through the translucent ceramics a bit. I'd have to start again in real life. So once we've trimmed it down and we've got something like the shape that we want, we can just give it a clean off, and then we go through the glazing process. So here I've got just the glaze mixed up. We manipulate this all over the surface, pushing it about, making sure it goes into all the nooks and crannies, right round to the junction with the metal, working it into the porosities. And then at this stage we can also apply some staining if we wish, or we can do them as separate stages, whichever we feel happy doing. So I've got the glaze on now, and now we can take some of the stain that goes with this shade and just tone it down around the cervical margin slightly, and then interdentally. And that just adds a bit more colour saturation to that part of the restoration and gives us this transition between the dark area around the cervical margin up to the translucent area at the cusp tip. We can increase the translucency just by putting some lilac or blue up there at the incisal edge. And once we're happy, that can go back in the furnace for another cycle. And that glaze is going to strengthen the ceramic by filling the porosity, make it hygienic, and of course make it more aesthetic. You can see just there I've got the opaque shining through the veneering ceramics. This is after it's been cooked then. This is the final result. A little bit of opaque showing through, a bit disappointing. And now we'd have to go through a process of polishing the metalwork at the back to make sure that it's smooth, the junction between the metal and the ceramic is tidy, and then the fitting surface would be cleaned and it'd be sent to the clinic. Okay.